Hello everybody, this is Itsu again. Temperature rising of the aluminium and copper bars inside the cache. I have my little temperature meter here. The cache has not been on all day, so it's at room temperature. And I zoom in of the copper pipe is 24.2.1 degree, and if I point it to the aluminium, it's also 24 Celsius. So I will turn on the cache now, and I will monitor the rising of the temperature by taking some samples. You can see that the streamer is now again to the outside of the aluminium pipe. You can see that the temperature is rising of the aluminium and now the copper. Oops. So there's a big temperature change in the few minutes that I have put on this cache. It could be, of course, this flame, this streamer, which is heating up, but the aluminium is now 35 degrees. It will stabilize, I think, but it goes fairly quickly from room temperature till okay, that is one thing I wanted to show you. And if you still are busy, then I will show you the temperature rise of my transistor in this few minutes. Also 44. Cache is out, is shut off now. But also the temperature of the transistor is rising fairly quickly. My hookup at the moment, what did I have? I have a lamp yesterday in series with this Capcoil. But the Capcoil I have now is a 30 microfarad motor start run capacitor. I have the AV plug, two N4007s, and I have this 250 volts AC, 360 volts DC lightning arrestor in series with the bulb 25 watt, and then back to a coil from magnet wire which is underneath this one. So it's a kind of loop I have from the capacitor to the lightning arrestor to the bulb and then back into this coil. Not sure how many turns, but there's a lot, 100 or something, and then back to the capacitor. And outside of this I have wound the other coil on which I will put some high voltage, and then you can see what's going to happen. I have to hook up my ground and I have to hook up my multimeter to see what's happening there. Okay, there we're back again. I have hooked up my ground to the AV plug. I have hooked up my float meter across the terminals of the capacitor. And I will start the cache. What you will see is that like the video from yesterday, that the cap will charge till about 300-400 volts, and then it will discharge. But then nothing happens. Then you will see that it will not recharge, and you will see a kind of plasma glow inside of this lightning arrestor, as if there is some internal in this loop internal capacitor coil loop, some high voltage being there, but it will not charge or load the voltage across the cap. Okay, let me show you if I can put everything in one shot. I've now connected the cache. You see the voltage rising. There was a flash of the bulb, and now you see no more rising, but instead you can see that the lighting arrestor is glowing. Of course the lamp, the bulb in series is doing nothing. I have this kind of voltage across the cap. I'm not sure what kind of signal there is inside this circuit. I think it's high voltage, but the problem is I cannot hook up my probe because I will short out. I will shut down the cache and then it shuts off the internal system. I cannot hook up my probe because it will short out one of the diodes, because one of the probes should be to ground. So I'm not sure what kind of signal is circulating when I do this. I will try to make a diagram of what this situation is and what is going on inside. I think there is some high voltage circulating in this circuit. Okay, this is a drawing of the circuit I just had. This side we have this external red 25 turns, which picks up the high voltage from the cache. This one is open. Internally around the cap I have this magnet wire, I think 100 turns or 80 turns, and that goes to this 250 volt spark gap lightning arrestor, to the valve, to the 30 microfarad motor run cap and back. And across the terminals I have this AV plug to ground, and I have the voltmeter hooked up. So what we see happening is that this high voltage is charging the cap till about, well, what is it, 250, 300 volts, until the spark gap fires. But then somehow this spark gap keeps energized. There is a short there, I think. So the new the cap cannot be charged anymore. It stays at a low zero at 1 or 2 volts. So somehow the energy is being circulated inside this circuit, I think. I have to stop the cache and then I can start over the cycle again. So this is a little bit the phenomenon I see happening in this little circuit. Not sure what to do with it, but it's a nice change from the thing I saw yesterday. Okay, concerning this diagram, in real life the spark gap and the bulb are reversed. So I have the bulb here and the spark gap is directly attached to one of the leads, and then going to the bulb. So this should be the other way around. I was thinking about scoping the signal. I can scope from ground till this point, and to see what kind of signal we have when the cap has fired and we still see the spark gap lighting up, to see what kind of signal we have there. So that's what I'm going to do now. I have hooked up my red probe at the plus of the cap, and I have my ground to the ground, where also the AV plug ground is connected. And Well, we are at 100 volt per division, and I will now attach the cache. You can see the climb of the, now it fired, and now it stays like this. I can crank up now the scope, and while we are still having this plasma inside and we have no real voltage over the cap, we have this kind of signal. It's a 7 volt peak to peak 1.3 megahertz signal, which is measured to be at this point at the terminal, the plus terminal of the capacitor. Only difference is that the gap is here, the spark gap is here, and not here like in this sign. I can try it again. I have to crank up the signal. What was it? 100 volts, and see again what is going to happen. You see the frequency grow. It flashes now and then it goes back, and then it stays at a lower level. Okay, try to get the probe on the other side and see what's happening there. Okay, I have corrected the little diagram. The bulb is moved to here and the spark gap here at the plus of the plus. It's not a electro gap, but the spark gap. The diode makes it positive there. Probably these are also the wrong way around. Okay, so I had hooked up the scope across this diode, and now I have changed it to this one. And let me check where the AV plug diode is. It should be the other way around, I'm sure. You can see the plus of the no, it's not visible, but the plus is on the diode with the anode here. So my drawing is again wrong here. Okay, but I will now fire up again the cache and see that we have the same waveform at the other side of the probe, on the other side of the cap, until it fires and then it goes back. And we have this 10 volt 1.3 megahertz wave. Okay, thank you for watching. Okay, I removed the aluminium pipe out of the cache. Only have the original copper pipe back. It's back to room temperature, 25 degrees Celsius. I'll now start the cache and see if I see the same increase in temperature like we did with you can see that also the flame, the streamer in the copper pipe will cause it to rapidly increase the temperature. So that had nothing to do with the interaction of the copper and the aluminium, I think. So also nice to know. Okay, stopping the cache for now and setting up for some other experiment. Okay, what else did I try? I tried to put two cap coils either in parallel like it is now or in series, but it doesn't make many difference. So I have now the first cap coil with the oscillating two coils inside, and I have parallel to the high voltage I have the single turn cap coil with the bigger bulb, 60 watt bulb, which yesterday in the video was loading this cap in 7 to 10 seconds before it fired. I've put it in parallel. I also did it in series with both coils in series, but the outcome is the same. You will see that when I power on the catcher, I have now both 2 multimeters across the both caps with an AV plug to ground both. When I put on the catcher, you see the first one will light the bulb, and then we have this oscillating plasma-like signal in the first one, and it stays stable. But the other cap is not really loading anymore. So there is a limit to the power that can be supplied by the catcher for the cap coils. They cannot be run in parallel and double the power or whatever. So I will now hook up only the 60 watt bulb to see how long it takes to load up with this setup. Then I've removed the double coil, cap coil, and I only have now this 40 microfarad capacitor with an AV plug to ground and a 60 watt bulb in series with the lightning arrestor. It's still charged, still about 120 volt from the other run. I will now hook up the catcher and see if it's able to load this. Yes, there it goes. So putting another coil in series of in parallel definitely has some influence of on the power that is distributed. So this is a 60 watt bulb. We can calculate the amount of joules that goes into the cap. At 400 volt it will fire. Okay, continue with the next experiments.